The aim of this lesson is to have a look at sort of an overview of binomial expansions and where you are going with what you're learning in the lessons. It's quite broken up in the lessons, and your textbook has some weird and wonderful ways of testing you in exercises. So I want to give you the context of where you're going, and then next week we shall do a whole lot of binomial past paper questions to really drive it into your heads. Okay, so first off, we're just going to start by a little bit of background because I'm not sure that everybody is at this point. So we're going to start from a bit of basics, and we're going to say, for example, x plus 3 to the 17. This equals something plus something plus something plus something plus and all sorts of other somethings. Okay, so what binomial expansions is all about is how do we go from this to these? But the question is, do we have to? So just to make sure that we are all talking on the same page first, this bit here, this is called a binomial expression. So it is two things in a bracket with an exponent. This bit here, when we get the this plus that plus something else plus another thing, is your binomial expansion. Okay, and it creates a polynomial. And each one of these is a term. So we have a term plus a term plus a term plus a term plus a term gives us our polynomial, which is our binomial expansion, which came from our binomial expression. So looking at one term in a little bit more detail, let's say we have 23x squared. Okay, there's a few things we want to note here. This here is the coefficient of x squared. This whole thing is the term in x squared. Okay, so we're going to identify our terms in this case by the power of the variable. For APs and GPs, we have that UK or UN, that identifier in the subscript. Okay, here it is the power of the variable that identifies the term. So I could ask you for the first 3 terms of this expansion. I could ask you for the term in x to the 6 of this expansion. And that's where we're going, is that when we have these enormous binomial expressions, we don't actually want to get the full expansion, because 99.9% of the time, in fact, thinking about it, probably in all of the past paper questions I've seen, you don't want the full expansion. You just want pieces of it. So in the same way, with an AP and a GP, if we were asked for the 8th term, we wouldn't calculate the first, second, all the way up to the 8th. We just calculate the 8th term. We would just calculate the 4th term. That is exactly the same as what we're going to be doing with binomial expansions. And it's a really important thing to understand. Yes, you can expand this out. Yes, you have a formula and you can get all the terms that you liked it or heart's desire, but that's not what we do. Okay? What we do is exactly the same as we do with APs and GPs. We pull out a specific term or 2 specific terms, or at the most usually 3 specific terms of interest that we want to work with. Okay, so do not go and randomly get lots of terms. I don't care how many you can get. I care that you understand the question and you can pull out the ones that you need to answer that question. Okay, so I have mentioned that we have a very handy little formula. What is the formula? We need a lot more space for that. We can say that a plus b to the n equals a to the n plus n1 a to the n minus 1 b plus n2 a to the n minus 2 b squared plus n3 a to the n minus 3 b cubed plus dot dot dot. Okay, so you can see this is not a simple and it is simple and straightforward. It's not a short way of doing things. Okay, there is a lot of elements here that you need to remember. So we're going to highlight a few things. First one is that is always your first term of expansion. Always a to the n. Here, this one is always the difference. And this one always matches. Okay, so we're starting to get some fun here. The other thing is, what is this n1, n2, n3, just in case you haven't got there yet? It is nr. We're going to talk about what n and r are in a few moments, but the other way of writing this is ncr, and this equals a button on your calculator. So you put in your n, you press your button, and you put in your r, and you press equals, and you get the value of whatever this comes out as when you have numbers in it. Okay, just in case you haven't got there yet. Remember also, if you're doing this lesson now and you haven't got to binomials, there's a whole lot more detail in the lessons. Okay, today we are working with an overview. So as you can see, right, we've got what's hiding here is an n0, an n1, n2, n3. It's changing, okay? But there's always an n and a something, and that something is an r. We've said that on the a is always the difference, a to the n minus r. And on the b is always the r. So now you have formula to calculate a single term. And in fact, we're going to highlight this because this is the number one best friend that you are going to have for binomials. I don't care that you have a nice big fancy formula above, which is in your formula sheet, because at the end of the day, this is the one that you're going to use, because the one above is going to get you a whole lot of terms in the sequence. It's going to start at the first and it's going to keep going. This one is going to calculate a single term. The single specific term that you want to work with is going to be calculated using this formula. So now we have some formulas. What else did I want to note? Couple of things. Always an A and a B and an N. Okay, so the full details of all of this, again, in the lesson in your formula sheet, but this today is about what do you really need to take home, that take-home message for binomial, so that you don't get into trouble in your assignment and come crying to me afterwards. So your take-home message actually is not in maths, it's in English. Your take-home message goes like this. It's about how are we going to use our knowledge? How are we going to use our understanding of what is a binomial expansion and use it in a question? First thing we do is we calculate the single term. So that nr, a to the n minus r, b to the r, how do we use that to calculate a single term? We also combine brackets. So let's just put here, e.g., I'll ask you for the term in x cubed. Then you must only ever calculate the term in x cubed. For combining brackets, here we would have things like x plus 1 x plus 1 over x to the power 14, and I would want the term in x cubed from that multiplication. Okay, so it's getting more complicated, but it's the same logic thought process that you're going to work with. And the third thing to look out for is finding the coefficient of a term. Now that sounds rather like you find a term, and it is. It's exactly the same as finding a single term from a binomial expression, from a bracket combination. But the thing is, when the question asks you for a coefficient, your answer must be a coefficient. They can't ask you for a coefficient and you give a term, because that's not what they asked you for. Okay, so you have to really, really, really look carefully. It is important that you understand what and why you are calculating. Remember that for AS Maths, we've got this big deal about communication. We've got this big deal about making sure our answer is communicated properly and making sure it is a simple and straightforward route from the question to the answer. So when you really understand the binomial and you really understand the power of the formulas that you're working with, then you are able to give this most direct, most straightforward route. And that's when you start getting your marks for these questions. Okay, so we're going to put more English on here. You're going to be applying your full knowledge and understanding. You're not going to be just putting brute force into these questions and plugging out loads of numbers and then saying, oh, there's my answer. You're just going to go, oh, there's my answer, first time. You're going to use all your formulas available. And you are going to take the simplest and most efficient route to your answer. On top of this, you have to have a good communication of your method. And that's the binomial. I mean, the binomial is those two formulas that we've just said. One in your formula sheet and then one for the single term. When you get into your first exercise with binomials, they're going to have you calculating a whole sequences out. Whole expressions, expansions, that's the one. Start with an expression, go to an expansion. So in your textbook, first exercise, full on, whole expansion. But that is just to get you doing these repetitive calculations, to get you splitting your terms, the three pieces, the three components that make up each term, your NR, your A to the N minus R, your B to the R. Do it over and over and over again. This is brand new. You've never done anything like this before. Okay, so yes, in your textbook, it makes you do that. But that is not where you are aiming and is not going to get you marks at the end of the day. So bear that in mind. You go through the slog to understand. That doesn't mean you have to carry on the slog. You then move above the slog to a better way of doing it. So let's actually today, we're going to already look at some past paper questions so that I can show you a bit more of what I'm actually meaning when I say things like this. Okay, so let me find it quickly. We should be back and you should now be able to see my PDF. Yes, okay, cool, brilliant. So what I've got here is just 3 little questions, just to show you what we're looking at when we get to past paper, when we get to this proper use of the formulas. Okay, so in this first question, we have an expression, a binomial expression here, 1 minus px to the 6th. P is a non-zero constant, bear that in mind. Find the first three terms when it's expanded in ascending powers of x. First three terms. That means you're just going to use that straightforward formula that's in your formula sheet. Plug it in, simplify. Done. Then it's given something, and now we've got one of these double brackets. So there it is. Okay, so now we're going to be a bit of a detective. We're going to come back. This is another question. Find the coefficient of x in the expansion of blah. We're not going to sit and do the whole expansion, and we're going to lose marks if we do. Okay, marks come from finding just the term of interest. If I asked you to find the 52nd term in an AP, you would not sit and list all 52 terms from A to the 52nd term. You would just calculate the 52nd term. It's exactly the same in a binomial. If I ask you for the coefficient of x, or Cambridge asks you for the coefficient of x, that is all you calculate. Okay, right. So, back to the beginning, to that long formula. What is the first three terms of 1 minus px to the 6? So, 1 minus px to the 6 equals, that first term is always a to the power n, so 1 to the power 6, plus n1. N is our exponent on our original bracket, so 6, 1, a to the power n minus 1, n minus r, so 6 minus 1, which gives us 5. Minus px is in our b position. Always remember to take the sign with your b position. And he's to the power 1, so he just sits there like that. Next one, 6, 2, 1 to the 4, minus px now gets squared, plus dot, dot, dot. We're only doing the first three terms. We are not saying the whole expansion is equal to only 3 terms. So we indicate, we communicate that we know there's more than 3 terms here. So now you can also see that with the exception of our first term, which equals 1, each term has 3 elements. Our NCR piece, our A piece, and our B piece. And that's what you're going to do every time you build a term. Okay, so 6, 1 is 6, 1 minus px, plus 6, 2 is 15 by 1 minus p times minus p, p squared, x squared, plus dot, dot, dot. And you see how I've simplified, but I've still kept all 3 elements. This means that I've got that chance to keep very careful track of my signs before I move on to combining. Now, 1 minus 6px plus 15 p squared x squared plus dot, dot, dot. There is my first 3 terms. And as you can see, magically enough, we have ascending powers of x. We have x to the 0, x to the 1, x squared. So we are happy. It's nice and straightforward. The thing comes in when they put things like minus signs in, and people lose track of their minus signs. So even though it is looking relatively simple, take the time to do it. 3 elements, simplify, combine. Right, second part. We have now 1 minus x, 1 minus px to the 6. And it is given that the coefficient of x squared is 0. So we have a 0x squared. Find the value of p. Now, in order to get x squared, I mean, this we would have to expand the whole thing. We'd have to look at this and this and this and this and what makes an x squared. And that's where we play detective and we think first. With a binomial, it's a great exercise in thinking first. Okay, so let's ignore our expansion for a little while. Let's say if we were going to multiply 1 by each of the terms in that full expansion without having the full expansion, if we were multiplying that 1 across, the only way that we can get an x squared term is to multiply 1 by the x squared term. So he needs the x squared term. And the same thing with our minus x. If we had that full expansion sitting there and we multiplied every term by minus x, the only way that we can make an x squared term is by multiplying our x by the x term. And then we smile, because the world is starting to make sense. Because 1 minus px to the 6 is what we dealt with in part 1. And look what we did. We've got a constant, an x term, and an x squared term. So from here, we can actually look for our x squared term. Our x squared term is going to equal our 1 times our x squared term, which is 15 p squared x squared, plus our minus x times our x term, which we've already got, minus 6px. And there it is. There's the terms that we needed. They just happen to be there. So if we simplify this, we've got 15p squared x squared minus 6p x squared. Whoops. Did you catch it? It's there. Minus 6px. So that becomes a plus 6p x squared. Be so careful of your signs. So we want an x squared term. So it's the same like when we did the discriminant. We're going to just do a little bit of factorizing to make things look nicer. And now we know that the coefficient of x squared is 0, which means that all our mess with these p's must equal 0. Therefore, 15p squared plus 6p equals 0. We have a quadratic. We can solve, taking out a 3 and a p. We're left with a 5p and a 2 equals 0. So this gives us then p equals 0 and p equals minus 2/5. But remember how way back a few moments ago I said keep that in mind? P is a non-zero constant. So given p doesn't equal 0, therefore p equals minus 2/5. So it really is about being a detective when you come to these questions. It's the same thing that you've been doing with APs and GPs, about being selective about what you're working with. It's just that you're working with different formulas now. So let's have a look at the next question. Really, my signs are just shocking today and nobody's shouting. P is minus 2/5. I hope that doesn't mean you're all just sleeping in the background. Okay, so find the coefficient of x in the expansion of x squared minus 2/x to the power 5. And you look at that and you think in your head, NR, a to the n minus r, b to the r, and you think, goodness gracious, how do I know which one it is? How do I know what r I'm using? And that's where all the stuff you did before with exponent equations comes in. There's a lovely little way of doing this. For the value of r, when we build our term, we're going to have an x squared, and he's going to be to a value of 5 minus r. We're going to have an x to the minus 1. He's going to be to the value of r. And we're building an x to the 1. So in the lesson, there's a lot more detail in how this process works and where it comes from. But this is the basic guts of it, okay? How are we going to build that term at the end of the day? And how are we going to work with our x's? So if we now build this out, we have x to the 10 minus 2r times x to the minus r equals x to the 1. Remember, we're using exponent laws just to simplify. X to the 10 minus 3r equals x to the 1. If our bases are identical, our exponents must be equal. 10 minus 3r equals 1 with a therefore. 3r equals 9, r equals 3. So now we know which term. We know which combination is going to give us a term in x out of these wonderful x squareds and x to the minus 1s. So we're not going to go straight to the coefficient. You can if you're happy to do that. We're going to go first to the term and then state the coefficient. So for x term, NR, well, N is 5, R is 3. A position, x squared. To the 5 minus 3 is 2. B position, minus 2 over x with its sign to the power, matching R, 3. Then we simplify each element. 5, 3 is 10. X squared squared is x to the 4. Minus 2 cubed is minus 8 over x cubed is x cubed. So we can now simplify. We can see we're cancelling and we're left with 1x. It's perfect. It worked. 10 times minus 8 is minus 80x. Question, however, didn't ask us for the x term. Question asked us to find the coefficient of x. So therefore, coefficient of x equals minus 80. Just the number, just what is multiplied to the x. Okay, and that is what so many of the questions are. Okay, it's all about pulling out which term is the important term. Okay, which term are you working with? And I see I've got some comments through after accusing you guys of sleeping that you are awake and you did see it, which is great to hear. Okay, here I got my signs right. I was a little bit more awake and keeping track of things. So you must do the same thing. Okay, it's not as ugly as it sounds. It's not as ugly as when you start, when you get into the binomial, when you get into that understanding of what you're doing and how what you're doing relates to the questions that are being asked.